Plate tectonics names Earth's elegant system of recycling rock back where it came from. It's creating new rocks with molten magma, and it explains other Earth phenomena, like how earthquakes can trigger an eruption, sinking Pacific Atlantic expansion, why mountains aren't uniform across the Earth, why there are millions of years between their birth, how the Earth created the diamonds we prize, and how continents change position and size. Earth's rigid outer layers compose the plates. Tectonics means large-scale motion at slow rates. Earth's composed of layers of metal and rock. Crust is a solid layer of ground we walk. Below the crust, the mantle is two sections. The upper part's the rigid crust connection. Earth's solid 100 kilometers down. Below that point, high heat and pressure are found. These conditions make rock and metal soften. Therefore, the lower mantle's rock is molten. Next is the core, which is also in two parts. Lower mantle ends where the outer core starts. The outer core is nearly the size of Mars, yet it's as hard to get to as distant stars. Composed of metal that's runny and liquid, extreme heat and pressure is what makes it fluid. Earth's outer core is always protecting us through the magnetic field which makes auroras. The moon-sized inner core is a mystery hid. We do know it's made of metal and solid. Those who have lived in the last few hundred years have seen maps of Earth as it truly appears. The puzzle pieces of land were hard to miss. Only then could observant people notice how the land on South America's east shore matched Africa's far across the ocean floor. Great minds like Ben Franklin suggested they'd split, and continents drifted to where they now sit. Not totally right, but a good place to start. The ocean plates play a much more active part. Only ocean plates are formed and then undone, and cause continent plates to be on the run. This was all unknown a century ago, like the cause of an earthquake or volcano. Weird theories and petty feuds had hid the truth, that these separate events were signs of Earth's youth. Finally, Alfred Wegener would implicate a wondrous process using moving plates. Harry Hess would provide data from the seas, indisputable facts that matched Wegener's pleas. Hess had found a mountain that was on the floor of oceans that were thought to be flat before. There he witnessed what he called seafloor spreading. He figured it drove continental drifting. So Wegener's simple theory was now complete. Those old beliefs couldn't stand up or compete. The plate tectonic theory had simplified, as many phenomena source unified. Its cycles of destruction and creation form earthquakes, volcanoes, mountains, and oceans. Ridges are sites of ocean crust creation. Molten rock extends plates from these locations. New rock pushes old like a conveyor belt. When it reaches a trench, it's pulled in to melt. Tectonics recycles rock in liquid state. Mantle convection helps it to circulate. Convection keeps the molten rock surface bound, where it can form a ridge or volcanic mound. Earth's two types of crust achieve distinct results. Land's granite is different than ocean's basalt. Both are igneous rock formed when magma vents. Different cooling creates their grain size difference. Basalt's iron-rich and consequently dense, while granite's light minerals give it buoyance. Plate boundaries have heightened tectonic action. They're places of dynamic interaction. Plates being forced together are convergent. Those that rift or rip apart are divergent. At ridges, plates diverge to form new sea floor. Convergent trenches form volcanoes on shore. Ringing the earth, keeping active construction, separate chains of creation and destruction. There's 7 large plates and a handful of small. In varied directions around the earth they crawl. Boundaries at Antarctic, Cocos, and Nazca are divergent, so they're releasing magma. Expansion continues in that area, with ridges near Africa and Australia. Around the tip of Africa the ridge winds, merging into the mid-Atlantic ridge line. Trenches are boundaries that will terminate the forward advancement of old ocean plate. They're found primarily in the Pacific and produce volcanoes that are prolific. Continental convergent boundaries differ since mountains are the result they deliver, like the many peak of the Himalaya that uplifted through impact with India. It's important to understand mantle convection because it's the link in the push and pull connection. While it may only be the passive middle section, it provides material and heats by conduction. Several locations need to accommodate the motion and evolution of a plate. If it's pushed and pulled, there must be a side where the plate boundary has to pass with the slide. When plates slide past each other, it's called transform. It's not as easy as it sounds to perform. The grinding pressure builds up and will discharge through hundreds of daily earthquakes, small and large. Rainforest remains in an Illinois mine are only explained through tectonics in time. Fossils found on separate continents would match because those land masses formally attached. Tectonics reassembled the continents many times in Earth's history of events. Foreign names like Laurasia and Gondwanaland were composed of the same ground on which we stand. These fleeting supercontinents demonstrate effects of plate motion in million-year rates. The last supercontinent was Pangaea. It amassed near the equator area. It was pushed together by the ocean floor, and it would be home to the early dinosaurs. Pangaea would dismantle eventually. As it did, it slowly birthed a new sea. Continents crept to their current position, although they're still in a state of transition. The breakup of Pangaea is ongoing, so the Atlantic Ocean is still growing. What will happen in a million years from now? Science and history predict where and how. Predictions from the future may not come true. It's so far away, who will be there to argue? Time and plate tectonics determine whether continents will again be pushed together, a subduction zone in the Atlantic's gashed, or peaks grow in Europe where Africa's smashed.